My name is Khvostionov. I'm the Chief Technology Officer of DigiLogic. And the presentation, as you can see, is titled Dart for IoT. I think everyone here at this point already knows what Dart is. So I'm going to try to tell you about IoT and how we are applying Dart to solve really complicated use cases. First, a little definition from Wiki. So the Internet of Things is defined as uniquely identifiable objects and their virtual representations. Now, when these things and objects all swarm and connect, now we start to get to interesting use cases that can be achieved. But IoT, as it stands, really talks about things. So if we look at things, we actually have a few over here that we're going to be looking at. These things are devices that are typically outputting telemetry data. And by the standard definition of IoT, if we take these devices and we connect them to the internet, excuse me, they become an internet-enabled things, hence the acronym IoT. What I'm actually here to talk about is IoE. IoE is something that actually now takes things, services, people, processes, and data, and these other devices and things to connect them together, to actually provide even more value. So when we look at cities of the future and all the management systems that are going to be running these cities, or islands, as we'll show you, this is what IoE is, Internet of Everything. Next, I'd like to show you the little things. So you can see here we have a little Intel Edison. We have a little robot that's connected. And we have an interface that was developed to control them. So what I'll be talking about today is all the technology that we built utilizing Dart. As you can see here, this is actually an application that was fully built in Dart. It's actually deployed as Dart2.js. You can see all the things that we brought today and how they're all interconnected. For example, I can use my phone as a sensory input device, and you can start to see that I'm rotating the phone, and this is all in real time. You can see the little Philips Hue light bulbs that I have right in front of me, changing their colors. Of course, we can do the same thing with a robot. I'll show that to you once I switch. But the robot can talk. We have an Android phone here that's running a piece of software, and we can make this Android phone talk. Sometimes. So all of these things that are connected together is what we're going to be talking about. So I'm going to switch back to the presentation to introduce a little bit about the technology and how it was developed. So let me start with our company. So the company is called DigiLogic, and we were founded in 2007. We set out to create technology to help build applications without necessarily being a developer. So we're utilizing Dart to build these applications, as I will later show you. Our core business is software for the Internet of Everything. Today we're announcing an open source effort for application enablement of Internet of Everything called Distributed Services Architecture. And another piece of software that we developed, and this is our commercial product, is called DigiLux. And this is what is used to develop applications that are linking all of these real-time sensors and pieces of information together. The products, everything I'm going to be showing you today, these are not proof of concepts. The demo was put together just to illustrate the concepts that are already actually being deployed and are already used commercially by our customers. And we have a very strong presence in building automation and business intelligence and visualization. So all of this technology has been vetted with our customers. Now, these deployments are global. We've utilized Dart to create a technology and a solution, and we're able to train other companies how to use the solution, and these companies are implementing the use cases that they see fit. For example, there are container ships that are being monitored by the software that I'll be showing you, all the rope tensioners and LiDARs, et cetera. And you can see the different types of use cases that have been developed and where the companies that are implementing those use cases are located worldwide. These are all our distributors. Now to the fun stuff. This is DGLux. It stands for the DGLogic User Experience. You'll notice its version is DGLux 5. It's because it's HTML5. The prior version was DGLux 2.5, so we kind of made a little jump. That version was made in Flex. We used to love Flex as a technology, the productivity that it allowed our developers to have. And when we started investigating moving to HTML5, we looked at many different frameworks, because that's what they are for JavaScript. And one framework would do something for us, another one, but there would always be some gaps. And luckily, we found Dart. It was definitely pre-release, but we deployed as a 1.0, or as a DGLux 5 release when Dart was still like 0.8 version. So we didn't even wait for Dart to become 1.0 to deploy the first commercial deployment of DGLux 5. What is this application? So you can see in the screenshot, it looks like a design environment. Well, DGLux, it's a what you see is what you get builder for applications. You do not need to be a developer to build any kind of HTML5, whether it's application or dashboard or some sort of interactive form. Really anything that you can see yourself building that is hosted in the web browser, that will run on mobile as well as desktop, you can build this in DGLux. The little screenshot you see in the bottom, this is data flow, because you can't build an application just to be a visual application. You need to create custom logic. If I click here, but some sort of drop-down has a value B, something else needs to happen. Right, so this is the data flow logic editor that is built into DGLux 5. Of course, there's a block for scripting, and you can use script to make custom functionality. But most of the time, we find ourselves, we can just use the blocks from the library to achieve any type of logic that we want. This application itself, it's more than 200,000 lines of Dart code. One of the things that we love the most, well, not the most, but one of the things that we love about Dart is the fact the rapid testing, rapid debugging. We're able to press play and we can see the results immediately, right away. This application has been in production since 2013. There's thousands of deployments of this globally. And the bugs that we see that are coming back to us, well, there are bugs. You can't really blame Dart for anything, for any of those bugs. And the way it's deployed is Dart2JS. Never really seen any issues with that. In the beginning, before actually using Dart, we thought that we would develop in Dart and we would compile it to JavaScript and we would have some sort of compatibility things. But we've been saved from that. So that's not an issue for us at all. Next, I'd like to show you some projects that was actually created using this tool and that are actually live. This is actually a data center, as you can see, and this is made for an iPad. The heat map is showing 700 data points that are all rapidly updating, showing all the different rack temperatures inside. And then you can see on the right a little bit of analytics. This is a smart island. DGLux was used to create the interface for it. It's monitoring solar power, wind turbines. This is a social media center. So if you go to conferences, you might see certain kiosks that are showing you real-time tweets and what's all the event information and statistics. DGLux is also used to power these. And again, these actually run on embedded WebKit devices. Actually, these screens are powered by devices that are using, as I mentioned, an embedded version of WebKit from Qt. So it's Qt WebKit. And of course, smart cities. Of course, utilizing other Google products, such as Google Maps, allow really nice interaction and kind of show holistic views of where all the data is located, as well as analyzing all of that information. So now I'd like to introduce you to DSA. I think the logo does it justice to explain really what it does. So DSA solves IoT. And what do I mean by solving IoT? When I said in the beginning, when IoT is considered, you're looking at a device, and this device is connected to a cloud or the internet. In my mind, that is not necessarily what IoT and IoE is, because in real production deployments, you always have other networks that need to connect to other networks. So it's never a direct connection from a device to a cloud. Even if you look at your home, you're going to have all of your home devices. Right now, it is transparent. So most of the connected devices for your home, you plug in your router, and they have a direct connection to the internet, and they're talking to the cloud. However, in the future, what we're going to see is a hub in your house. So all the devices are connected to some sort of hub. This hub might be connected to other hubs that are in your neighborhood, because when everything is going to be connected together, which is what Internet of Things and everything implies, that means all of these devices in your home and let's say the light pole outside, as well as a traffic signal, because it knows that you just left your house, all of these things will be connected. And in order to properly connect them, it will be connected as networks of networks together. DSA is an open source platform. DSA was really created for us. It's a little selfish reason initially, but we started it because DGLux, the visualization technology that I showed you that is used to build applications, we will sell more of it when there's more data available. That is the reason we made DSA open source, is that we want the community, we want everyone to build applications that are sitting a little higher level, that are utilizing all the connectivity and all of the, if you will, device profiles and device abstractions that DSA provides. So you can think of DSA as taking all of the code libraries that are available for the interoperability of the different devices and joining them together into something that is normalized, something that can work together, so that your Philips Hue knows about maybe the Nest thermostat. To get into a little more detail and how Dart was utilized, here's a logical diagram. As you can see, we're going to start top to bottom. So whenever we talk about a device, and the devices that I have here, you're always going to start, well, how do I talk to the end device specifically? Some devices will implement an HTTP-based protocol. Some devices will implement, like Bluetooth LE or Bluetooth 4.0. At the end of the day, you can't ever predict really what your endpoint and what your edge device will use. In industrial automation, we're still using RS-485 communications, which is really slow serial protocols. So what we've done is we've abstracted this logic, and we're trying to think about it as a black box, and we call them DS links. So if I create an implementation for a Philips Hue, I'm going to create a Philips Hue DS link, and that's what you can see here that's running here. All of these links are connecting to a broker. So you can have multiple links that are going to connect to a broker. And what that's going to do, that's going to allow the links that are connected to the broker with proper permissions to talk to other links that are also connected to that broker. So you're now able to have devices that are communicating, devices or things or services, communicating to each other through the central, if you will, broker node. Because we're normalizing the proprietary, let's say, protocol of Philips Hue or the MIP robot or whatever else is connected, we're normalizing that right in the DS link. We can always treat a DS link as a black box, and all of the data that's coming out of it is called Node API. So brokers themselves can also be connected to other brokers. So now you can see how we can form this kind of graph of networks and graphs of connected things. And if you want to build an application, which I really hope that you do, because the whole point of open source in DSA is to drive the community effort so that everyone can contribute new services, new functionality, new protocol converters to this effort. The types of links that are possible include, as you can see here, of course, device drivers, but also things like historians. So once all of this activity is happening, maybe I want to start logging this data into a Hadoop database. So that's also a link, because it has access to everything that's going on in a broker. You can just plug this link in, it'll start logging all that data and exposing it to whoever wants to now get this historical data. If you would like to do analytics or machine learning, there's really great projects out there like Apache Spark and the machine learning library that is included there. So these are all the types of links that you can create. DGLux itself, the user experience I showed you, that is also a link, right? So that is also connected to a broker, and that just gets all the data that is on the broker, and you're able to browse it, as I'll show you. The way DSA was created is the reference implementation is 100% Dart. Underneath, it's using WebSockets with HTTP fallback for communications. And we've seen really good performance. I don't know if you saw when I was spinning around my phone, it was really, really quick. And that actually transfers all the way down to the edge of the network as well. We also have currently ported the Dart SDK into Java and Node.js. So even in this demo, we have Node.js DS links, there's Java DS links, but they're all connected to the Dart broker. So now we have this language interoperability happening. On our roadmap, and we really hope community can help us with this, is to just make SDKs for DSA in all the various languages. Because what we believe is that there's existing software out there already created in some language that we want to utilize as part of this Internet of Everything. So if there's a SDK that is in that native language, it's much easier to plug this connected functionality into that existing piece of software. Now let's look at this demo again that I was showing you. And let's look at it in a little more detail from the point of view of what I just explained to you. Sorry about that. That's coming a little later. So we have the Intel Edison that I showed a picture of earlier. And this is a very small embedded device. And I'll actually pause for a couple of seconds while I talk about it and show it to you on the big screen. So all of the connected devices are actually running from this little Intel Edison. It is running the Dart VM, so it's running the broker. It is running a Dart web server, which is where you're seeing DGLux being served from. It's also hosting DGLux, so it's hosting all the graphics. It's hosting the development environment, so you can actually build and visualize everything. It's also running a little node for to show interoperability with other languages for communicating, let's say, with the Philips Hue lights. And this Intel Edison is actually connected to another gateway. And you can see here in my interactive diagram, this little Dell Industrial Gateway. Now, this Dell Industrial Gateway, that's running the Dart broker as well. And if you're curious about the operating systems, the Edison is running Yocto Linux, and it's really stock. You can just you can install everything. If you buy an Edison, you don't even need to flash it, so it's going to work. And the Dell Gateway is running Ubuntu. Now, that's connecting to our cloud. Well, our cloud is on purposely underpowered micro instance on Amazon EC2. Because what we're trying to do is really show connectivity and performance. And when you're dealing with billions and billions of devices, you really want to develop on very, very small platforms so that you can, it's much easier to use more CPU than less. Right? So all of our development is really taking that into account. So the Android phone that I have here is actually connected to this cloud. The link that I'm running on my phone itself, that's also connected to the cloud. Now, if I jump back to this screen, you will actually see that it's actually a little Polymer application right here that is created, and it's using the HTML5 standard APIs to just pick up all the accelerometer and all that different data and send it over to DSA. So you don't even need to be running the connectors for DSA server-side. And that was a very big goal for us, because what we really wanted to do is utilize the internet for all communications. You don't want to open holes in your firewall. You don't want to create routes just so you want to control something. Because when we're talking about all of these connections, at the end of the day, even when I'm entering my cloud endpoint, I still have, with permissions, full control of the devices that are maybe 3, 4 levels underneath. And that's really important. The Intel Edison also has a little board on it, so you can see the temperature that it's outputting as well. And if I play around a little bit with lights, you can see me changing the light colors. If I blow on the Edison, you can see the temperature gauge changing. So the robot's getting a little tired. Now that we have kind of all of these things connected, we can start to build logic. Now, logic, as I explained earlier, is built utilizing data flow, such as this. So this is a very simple data flow that is going to be driving a game that we're all going to be playing a little later. I'd like to show you another little demo because once this data starts flowing and we have our phone and you can see we're spinning it around, we can bring up and discover some interesting novel control concepts. So now I can use my phone as a dial to change the hue, as you can see, brightness on this right bulb. But as soon as I flip my phone around, I can start controlling the other bulb. Right, so now the phone is utilized as an analog gauge. And surprisingly, this is not something we built. As soon as we connect everything, and all this data is there for us, and it's flowing, because what DigiLux allows us to see, and if I actually zoom in a little bit, maybe it's going to make it easier for everybody to see that. But you can see all of this data that's flowing. So if I bring up our iPhone DS-Link right here, you can see all of the sensor readings. And I can actually show you how something like that is created in DigiLux. We can drag out an iPhone image in edit mode. Here it is. DigiLux has all the different tools for all the graphical manipulations that HTML5 allows, so it supports pretty much every single of HTML5, and it exposes that for you in a graphical, what you see is what you get environment, including, of course, transform. So you can see the phone, HTML5 API is outputting alpha, beta, and gamma. So I can take these metrics that are live, and I can bind them directly. This lets me do some conversions right on the fly as I'm spinning the phone around, but in this case, I don't need to do anything. Notice that I can even move it around, and it's still reacting to all the changes that I'm showing you. So this is always truly what you see is what you get, and always live. So if I link alpha, beta, gamma, you will see how everything really ties together. So I'm sure you've noticed this by now, but what we're really trying to do is we're trying to open data up. We've created a solution that is open source, not just open source with a commercial license clause, but it's truly free. There is no commercial licenses for DSA. It's licensed under Apache 2, and we're trying to democratize data. So we're trying to create an open source platform that will connect all these devices, services, and things together in such a way that, like us, that can build a commercial product on top of all of this live streaming data, you can also create commercial or potentially open source products on top of all of this data. All the code is available on GitHub, and you can always go to iot-dsa.org to see the website for DSA. Now, I also want to call out the DigiLogic DSA contributors. You can see them listed here. These gentlemen contributed pretty much all the source code that you see right now. We do have a few external contributors already, but this is one thing that I would really like everybody to walk away from. You know, for us to really, truly have this connected world of the future together, we cannot be relying on a proprietary system that's going to be taking all our data and marshaling this. In a perfect world, the system is going to be created in Dart, and it'll be DSA. Now it's time for a game. So if everybody that's connected or online can go to this URL, and I will actually also put it into Slack as well. That's set up for the Dart Summit. I will show this in 1 second. It's in Slack now. This is the URL, game.iot-dsa.org. I'm actually going to bring it up on my phone as well. So we can see how many players are coming on already. Now, this wasn't done on purpose, but everything I just showed you, including our company name, starts with a D. We have DigiLogic, DigiLux5, DSA, and Dart. So I guess it's a marriage made in heaven. So I guess I'll give everybody a couple more, maybe 30 more seconds to join. It's game.iot-dsa.org. Good. We're using you guys for a test. We see, oh, it's not responding because the game isn't started yet. So it's not hanging. We're just waiting for everybody to log on. Well, I think we have enough people. So let's turn it on. Because as I said, that this whole game, what we're doing, and the goal of this game is you're going to be tapping the randomized button color that was provided to you by the sweet random number generator in Dart. And we're going to see whose team is going to win. So, and you'll notice that this game is actually called Performance Test. So I'm going to go ahead and we're going to enable the game. But wait for me, I want to play too. Okay, now it's enabled. Wow. Everybody click, 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 click. Oh. My phone is, there it is. That's a lot of clicks. And that's a lot of players. Come on, help us test our micro EC2 instance and Dart VM and Dart2JS and WebSockets. This is a test for everything. So while the game is going on, maybe anybody has some questions for me. I think there's about 3 minutes left.
Is there anything in DigiLux that's not a DSA?
So DigiLux is our commercial product.
Can you repeat the question?
But, okay, so is there anything in DigiLux that's not in DSA? And what I was going to say is that DigiLux is our commercial product, so it's using all the APIs of DSA to get the data, right? And we actually have sample applications that are doing exactly the same thing as DigiLux. It's written in Dart and Polymer, and you can see that on GitHub, that are pulling the data and visualizing and subscribing in all the same ways. But the DSA is really the underpinnings. Now you can see that Philips Hue is telling us who won already, who's winning, by the way. Yes?
Here, let me bring you a mic.
So in theory, what you could do is you could have a set of microphones pulling in some audio data, and then you could kind of pull that in and actually use it to control color of the hue light. You could, certain frequencies come in, have the light come in a certain color,
absolutely.
and change all that.
Just like the winning team is showing on the Philips Hue.
Yeah, same.
Can maybe squeeze one more question in? Anyone? Raise hands. get Kevin to give you his microphone, or I'll give you mine? Sorry, you guys are too busy tapping right now.
Here's a question back here.
Kevin will bring you the mic.
You mentioned that you're just using standard ports, port 80, I guess, on the incoming to the devices or anything
Yes.
like that. What other security concerns do you have for malicious, I guess, attacks on the devices? Because if you're just throwing it out there on port 80 and not doing any other ports or locking it down anyway and you're allowing any traffic inbound, I can see a potential for security concerns.
So the question was, what type of security are we implementing? Because we are using the internet as a backbone for all communications going on port 80. So what security measures are in place? Now the answer to that is, it's not just you connect to the port 80. It's not a REST API. REST API wouldn't really work in this instance because we need to have a device, everything that connects upstream. Because you'll notice you're playing this game on the cloud, but it's actually controlling the Philips Hue bulbs that are connected to this Intel Edison through 3 different hops. So there's a handshake mechanism that happens, and it's the device that connects to the broker. You can never connect to this device directly. You cannot connect to a DS link. So it connects to the broker, and the broker whitelists it. So nothing is going to happen until that device becomes whitelisted. And we do have security for handshakes and other aspects of DSA. And I personally believe security by openness and not by obscurity. So it's all right there for you to see in the code and comment and take a look at our documentation and to spot vulnerabilities and to help us fix them. And that's what we really hope is going to happen.
I think we're probably good on time.
Thank you so much.
So who won? So
Who won?
all right. So we're going to do a test. The first person that shows me their phone gets the robot. No, I couldn't do it. But I think you were first here. Because this robot has broken already. It's already broke.
Do I need to bring up the code of conduct again?
Make it,
No, Bob, that is legal in California, actually.
So you can connect to it using Bluetooth LE, and this robot has a mind of its own. So it's actually broken already 6 different Philips Hue bulbs. So yeah, okay, well said.
Thanks.
Thank you very much,
Round of
everyone.
applause.